Hey everyone, so in this video, we're going to be looking at lesson 13.8, which is about construct arguments or constructing arguments. This is the last lesson in topic 13, so just keep that in mind. And then this is also one of our math practices and problem solving lessons, as you can see right here. So it's not necessarily just about the skills that we've been looking at and like learning in topic 13. It's focusing on the math practice, and in this case, it's construct arguments. So our I can statement is I can construct math arguments using what I know about fractions. So using our previous knowledge about fractions, we're going to construct arguments like give good reasoning, why we think it's the answer, and based off what we already know. So our solve and share says Lindsay and Matt are running in a 1 mile race. They have both run the same distance so far. Write a fraction that shows how far Lindsay could have run. Write a different fraction that shows how far Matt could have run. Construct a math argument to support your answer. So I'm going to go with my two fractions. I'm just going to write them. I'm going to put 2/4 for Lindsay, so on top, and I'll do 4/8 on that. So I would say that Lindsay has run 2/4 of a mile and Matt has run 4/8 of a mile. 2/4 and 4/8 show the same part of the whole. They show Matt and Lindsay have run the same distance. So I can also go here. Do this again and just show the two fractions. I have my 2/4 and then I have the 4/8. Yeah, so they match up perfectly here. You could have chosen other fractions for this problem, but these are just the two that I found. And also, sorry, went to the school YouTube page on accident. It says construct a math argument to support your answer. So besides just saying that 2/4 and 4/8 show the same part of the whole, I could say that 2/4 and 4/8 are equivalent fractions, and they are on this at the same point on the number line, as well as saying that they show the same part of the whole. So that would be part of my argument to support the answer, saying that I know that they're equivalent, that they are at the same point on a number line, and that they make up the same part of a whole. The thinking habits right here says, be a good thinker. These questions can help you. So these are questions that you can ask yourself while you're solving problems, just to, if you are maybe getting stuck or you aren't sure where to go in your problem or like which way to solve it, ask yourself one of these questions and see if it helps you. So the questions are, how can I use numbers, objects, drawings, or actions to justify my argument? So in this case, the numbers I used were 2/4 and 4/8. I could have done a drawing of these fraction shifts, but I also just used those, so those could count as objects. And then, am I using numbers and symbols correctly? I didn't add anything or multiply or divide or subtract anything or like compare any numbers in this, so I don't have any symbols to look at, but I do have the numbers to look at to make sure my numerators, my denominators are correct, the correct values I want to use. And then, is my explanation clear and complete? I think that my explanation is clear and complete because I gave 3 reasons why, or 3 reasons why I think that my answer is correct and to support my answer. So I feel like I gave all of those, and even if I had only given one explanation and one solid reason, that would be enough to say that yes, my explanation is clear and complete. So this bottom part down here says, are the two fractions you are equivalent? How do you know? Again, it's kind of restating maybe some of the facts that I included in my argument up here. But are the two fractions you are equivalent? How do you know? Yes, they are equivalent because they are at the same are on the same spot on a number line, and also they both represent the same part of a whole, and in this case, they both represent the same part of a mile. So again, I know that they are equivalent because they are at the same point on a number line or on number lines, and they represent the same part of a whole or the same part of a mile in this problem. I'm going to clear the screen so it's a little drawing on the side. Go to the next page. Our essential question is, how can you construct arguments? So again, we're going to really be paying attention to box B because it's similar to our good thinking habits and questions we looked at the page on before. So it says, Clara and Anna are making rugs. The rugs will be the same size. Clara has finished 3/4 of her rug. Anna has finished 3/8 of her rug. Who has finished more of her rug? Conjecture, Clara has finished a greater portion of her rug than Anna. So conjecture, just like your answer for it, her argument is that, like the start of it, is that Clara has completed more. So this right here says a conjecture is a statement that you think is true. It needs to be proved. So again, it's her argument, it's her answer, and then she still has to give reasons why. I need to construct an argument to justify my conjecture. So she knows that's what she would need to do next. Here it says, how can I construct an argument? Again, similar, almost exactly the same, but similar enough statements instead of questions like we had on the previous page. So I can use numbers, objects, drawings, or actions correctly to explain my thinking. So instead of am I using these things correctly, they're saying these I can statements are I can use them correctly. And then I can make sure my explanation is simple, complete, and easy to understand. Instead of asking yourself, is this simple and complete and easy to understand, you would say, I can make a statement, or I can make sure that my explanation is simple, complete, and easy to understand. For C, I will use drawings and numbers to explain my thinking. So here we talked about possible things that you say you can use to further your explanation, and she picked numbers and drawings. Here it says the number lines represent the same whole. One is divided into fourths, one is divided into eighths. So it shows you the two number lines. They are lined up perfectly for you. And this little guy is saying, here's my thinking. So his thinking is that he'll use the numbers and drawings. And then it says the number line show that 3/4 is greater than than 3 of the eighths. Oh, I stumbled on that. So if we look here, this is where Clara is, and then 3/8 is where Anna is. You can see right here on these two number lines, as they're compared with each other, that 3/4 is more than 3/8, and they use the little symbols here. Even that 3/4 is greater than 3/8, the conjecture is correct, so her answer is correct, her statement is correct. Here it says use numbers to construct another math argument to justify the conjecture above. Think about how you can look at the numerator and the denominator. So I'm just going to write the fractions over here, and this is I'll be referring to these as I'm giving an explanation. So our two fractions are 3/4 and 3/8. So these two fractions have the same numerator. They have the same top number. I'll just circle those. Same numerator, same numerator. So I can compare the denominators. So then I have to look at the bottom numbers to further my explanation. So I have a 4, try to make it like square-ish, and I have an 8. So I'm comparing these two denominators. So I know that the fraction with the smaller denominator is the greater fraction. So in this case, 4 is less than 8. So I know that 3/4 is greater than 3/8. And another way just for me to try and see this is that if you were to think about something, if you had 4 pieces, we're gonna go back to pizza. If you had 4 pieces of pizza and you ate 3 of those pieces, you only have one left. If you had 8 pieces of pizza and you ate 3 of them, you have 5 left. So we're really far away from making a whole right here to making it 8/8, and we're super close. We're only one away here from making it 4/4, which would be a whole. And again, looking and trying to figure out how far are we away from creating the number one, like in creating numerator, denominator being the same number, whichever one we're closer to will be the greater fraction. I'm going to clear this page though. And last but not least, so for this part, they give us some specific instructions, at least for our number one right here. So it says Paul and Anna are eating burritos. The burritos are the same size. Paul ate 4/6 of a burrito. Anna ate 2/3 of a burrito. Conjecture Paul and Anna ate the same amount. So we need to see if 4/6 and 2/3 are equivalent fractions. Just draw a diagram to help you justify the conjecture. So you could draw a number line for this. I am just going to go back to these fraction strips and these off. So the two fractions we're looking at are 4/6. So 2, 3, 4. So we have 4/6 and then 2/3. So they do match up perfectly, so they are equivalent fractions. So I drew this. If you chose to draw a number line or anything, another model of some sort, that's fine. Or any type of drawing. I just chose the diagram I would use for this would be the fraction strip drawing. Another one, like I said, you could have used number lines like they did on the previous page in box C to compare the two fractions. For C, is the conjecture correct? Construction argument to justify your answer. So for this, based off of the fraction strips that I have here, I would say that 4/6 and 2/3, I would start off with Paul and Anna did eat the same amount of a burrito. 4/6 and 2/3 are equivalent fractions. I know they are equivalent fractions because they take up the same amount of space when using fraction strips. So Paul and Anna did eat the same amount of a burrito. 4/6 and 2/3 are equivalent fractions. I know they are equivalent fractions because they take up the same amount of space when using fraction strips. Now, if you did draw number lines, your argument could go along the lines of, well, 4/6 and 2/3 are at the same spot, or they are the same place on a number line, or they match up on number lines. Okay? And here it says an example can help you construct an argument. So this drawing helps me with my argument down here. Sorry. This drawing helps me with my argument. And if you use number lines, it can also help you with your argument as well. So down here, for 3, 4, and 5, we're going to use this third problem. It says Raina has a blue ribbon that is 1 yard long. Oh, sorry, guys, I just keep yawning. So Raina has a blue ribbon that is 1 yard long and a red ribbon that is 2 yards long. She uses half of the red ribbon and 2/4 of the blue ribbon. Conjecture, Raina uses the same amount of red and blue ribbon. So for this, I am going to draw a picture of this. Actually, I can just use fraction strips first, and then I'll also draw a picture. Oh, I'm trying to get rid of this. So we have a half, and then we have 2/4 here. So they do line up perfectly. That was my fraction strip. Sorry, I just clicked off that really quick. So my half fraction strip and my 2/4 fraction strip line up perfectly. And then also if I were to draw a picture here, I'll do my best if I can. Oh, that's not good. That's okay. Come it over perfectly even. So these represent the whole, and then I'll just take another color and color these in. So the 2/4 is this one, and then half is here. So again, it's just a drawing, and I have filled in the parts that they used of the ribbon. So right here, it shows that they line up like almost perfectly. If I would have drawn them a little bit straighter, it would have. So that would be my drawing or my diagram that I would have here. So either a picture looks like this. If you chose to use number lines, that's also okay. Or if you chose to use fraction shifts like I did here. Here it says the constructor correct. Construct an argument to justify your answer. So for this, I'm only going to give one because I can argue that number 5 says explain another way you could justify your response. So they are not equivalent fractions. First, I want to make that clear, and I want to tell you why. Because the red ribbon, and I use these in color coordinated, it probably would have been easier, so I apologize in advance for that right now, or like in delay, I guess, because I should have already color coordinated them. So Raina's blue ribbon is 1 yard long, and her, I don't know why I used orange for that. Okay, that's fine. And then our red ribbon, that is 2 yards long. So do they match up perfectly? Yes, great. But what we need to keep in mind is that the fractions both equal half, so they're both like half of one whole, but they don't refer to the same size whole. So again, as I was explaining that before, I apologize. I can see how it could be confusing now, and I should have clarified that before I even started, but I didn't, so I'm sorry. So they don't refer to the same size whole, so they're not equivalent, and they're not equal in size. So if I were to use this here and making a bigger drawing, would probably have made more sense. So again, apologize. This one was definitely not my best explanation, but it's the last video for this lesson. This topic. See, still getting confused on it. So I just apologize for this whole part down here. So they don't take up the same part, or like they aren't the part of the same whole because they're two different sizes. So like the blue ribbon is 1 yard, the red ribbon is 2 yards. So even though they do match up like this way, if we were talking about just the actual fractions, like here on my fraction strip, then they would match up perfectly, but they are not the same size whole. So my answer would be no. And then I could use fraction shifts to show, for number 5, I could use fraction shifts to show that the holes and the two amounts of ribbon are not the same size. So if I were to like basically, let me see if I can try. We're gonna try again with these fraction shifts where I can explain my second reasoning. So that's 1 yard, this is 2 yards. So here it says she uses half of the red ribbon. So she uses half of the red, and the red is 2 yards. So she uses half of the red ribbon. And then for this, she uses 2/4 of the blue ribbon, which would just be this. So sorry, this is the picture I should have shown you originally with the holes included. So like this, this is 2 halves. No, this is half of like the whole, which is 2. So again, this is a mess. I'm sorry. This represents the red ribbon because this was 2 yards long, so this is 2 yards, and she used half of it. This represents the blue because it was only 1 yard, and they only used 2/4 of it. So this would be my fraction ship showing that, using the wholes and showing the fractions that they gave with them. Um, with that kind of a mess of an explanation done, I'm just going to clear all of this. If you have questions about this, please let me know. I will try and explain it to you better, possibly maybe if I explain it to you one-on-one. If you are really struggling with it, that might work better. Or if you're struggling with any of the other parts of 13.8, you can let me know. And like I mentioned in the Zoom, since this is not a part of this skill, like lessons necessarily for this topic, and we have talked about constructing arguments before, and it's something that you will continue to see throughout this like series, throughout the math series, no matter what grade you're in. You'll have plenty of time to work on constructing your arguments. So this is the end of the video. If you have questions, please let me know. And yeah, let me know that you watched it. Okay, bye guys.